Everybody, coming at you for week 4 virtual learning. So we'll be doing lesson 7, and we're going to be talking about whether a point, an ordered pair point, is a solution to a linear equation. And another way to say that would be, is this point on the line? Yes or no? And I'm going to give you 2 different ways to do this: an algebraic way and a visual way. And then for your homework or your assessment, you're going to be testing out whether you can identify, yes, it is a solution, or no, it isn't. So really hope you've all been doing well. The weather's been great, so I don't know if that helps or hurts with wanting to sit down at a computer and get after it. But, it's been, I know with my young family, the days that we can get outside and do stuff seem to be a little bit easier days. Kids seem to be happier and more productive, and I just want you all to know how much I'm thinking about you, and how I know this isn't ideal, but it's what we're working with, and I want to make sure that you're using those office hours if you come up with anything that's giving you a hard time. There's a little change this week. Instead of Wednesday, it's Friday due to a meeting conflict I have. And I just want you all to know I'm working hard for you, and I'm wishing you all the best. So let's get into the math here. So again, the question we're asking is the ordered pair a solution to a linear function? So we know a linear function is a function with each domain has one range, and it's a line. It does not have to go through the origin, although it could. And we've used function tables to show these. We've used graphs, and we've used equations. So big picture, is the point on the line? So first we're going to look at point -3, -1. So algebraically, I want you to remember that this ordered pair xy is x and y in an equation, a linear equation. So the first way I'm going to test this is I'm just going to substitute in my x and y values. So y is -1, x is -3. And so if I simplify both sides of my equation here, my 3's cross simplify, I get a -4 plus 3. -1 equals -1, which is true. So it looks like this one is true, but let's confirm it with a visual. If I go to point -3, -1 on the graph, it is right there on the line. So the thing I want to point out, it's just one of the solutions, right? There's infinite numbers of solutions. This whole line forever. Anywhere on that line forever is a solution. We're just testing out, is this a solution? The answer in this case is yes. All right, here, let's look at point -2, -3. Again, remember, ordered pair is just an x and a y. So y is -3, x is -2. And when I simplify, these cross simplify. And I get a -3 equals -3 minus 5. -3 equals -8, which hopefully is striking you as odd. That's not true. So we're going to say that this one is false, but let's go confirm with the visual. Point -2, -3 is right there, and that point is not on the line. So no, point -2, -3 is not a solution to the linear function y equals -3 halves x minus 5. Okay, let's check this out. We got function y equals -5x. We've got xy coordinates for a point -1, 5. I'm going to substitute in my x and y, and I get 5 equals 5, which is true. Let's confirm with the visual. Point -1, 5 is on the line right up there. Great. Last one for us. We're going to say, is point -2, 0 a solution to the linear equation y equals -8/3 x minus 5? So let's substitute in our x and y values. And I get 0 equals 16/3 minus 5. I think that's easier to think of as 5 1/3 instead of 16/3. And that gives me 0 equals 1/3, which is like kind of close, but it's still not true. Not true. So that would have to be false. And let's go check the ordered pair. -2, 0. Oh, that is really close. Look at that. Close, but it's not it. So that is not a solution to the function. Alright guys, feel free to watch that again if you need to. I know it's kind of quick, but it's intended to be. Just letting you all know I miss you a whole lot. I hope you're doing well, and like I said, do not hesitate to reach out. I got you. Anything you need. Be good.